Welcome to this comprehensive guide about Google-managed TLS HTTPS certificates. Today, we'll explore how to efficiently manage SSL certificates on Google Cloud Platform. We'll begin with key concepts before moving into hands-on demonstrations. Let's start with the fundamentals of certificate management. Managing certificates manually can be challenging and time-consuming, which is why automated solutions are preferred. While there are open-source options available, such as the Cert Manager project, cloud-specific solutions offer better integration. In particular, Google Cloud Platform's Certificate Manager and its Google Managed Certificates feature provide a seamless experience. This service works very closely with Google Cloud's load balancing system. For those seeking a complete, ready-to-use certificate management solution, the recommended approach is to place Google Cloud Load Balancing in front of your application. Your application can run on various Google Cloud services, including Compute Engine, Google Kubernetes Engine, or Cloud Run. In our demonstration today, we'll focus on a simple setup, deploying a basic application on Cloud Run with Google Cloud Load Balancing in front of it. You might wonder why this service is so tightly connected to Google Cloud Load Balancing. The answer lies in how SSL certificates work with ACME challenges. When validating certificates, you can use either HTTPS-based or DNS-based ACME challenges. When you have a load balancer in front of your application, it can manage the HTTP ACME challenges automatically. While DNS challenges are possible if you're using Google Cloud DNS for your domain services, Google doesn't assume everyone uses their DNS service for domain management. Therefore, the HTTP approach through load balancing is more reliable and universal. An important point to understand is that your application doesn't need to handle these HTTP challenges at all. The load balancer manages specific URL paths that satisfy the certificate maintenance requirements. Our first step is getting an application running on Cloud Run. We'll navigate to the Cloud Run service and use the Test with the Sample Container option, which provides a basic Hello World API. This sample container gives us a simple starting point. When setting up the service, we need to enable unauthenticated invocations and ensure the service is active. For the Cloud Run service, we need to select a region. In this demonstration, we'll use US Central, though you can choose any region that better suits your needs. The default configuration settings are sufficient for our purposes, so we can proceed with creating the service without any additional changes. After the service is up and running, we'll test it using the URL provided by Cloud Run. When we see a successful response, we know our basic setup is working. However, to enhance security, we'll make an important configuration change. We'll restrict the service to be accessible only through application load balancers. Once we save this change and the update completes, direct access to the URL will be denied. This ensures that the service can only be reached through the Google Cloud Load Balancer we'll set up next. Now we move on to setting up load balancing. If you haven't used the Compute Engine API in your project before, you'll need to enable it first. While this activation is processing, it's worth noting an important best practice. Although we're using the Google Cloud Console's graphical interface for this demonstration, in production environments, it's recommended to provision resources using Terraform and infrastructure as code. This approach improves how you can manage, reuse, and quickly deploy your infrastructure. When setting up the load balancer, we need to use an application load balancer that operates at layer 7. This is crucial because it allows the setup of HTTP endpoints in front of our application, which are necessary for the HTTP ACME challenges we discussed earlier. The load balancer must be public-facing to allow the ACME challenges to function properly. Initially, we might consider using a regional load balancer since our backend is regional. However, we'll discover an important limitation. Google managed certificates are not supported on regional load balancers. This means we'll need to modify our approach and use a global load balancer instead. For our managed certificate setup, we first need to create a properly named IP address. Then we can proceed with creating the certificate using Google's Managed Certificates feature. For this demonstration, we'll use the domain demo.notomatic.io, though in practice, you'll need to use your own domain and point it to the load balancer's IP address. During this setup, we'll also enable the HTTP to HTTPS redirect, which is a security best practice. Moving to the backend configuration, we need to create a backend service specifically for Cloud Run. This requires setting up a serverless network endpoint group for Cloud Run. Since we're running in US Central 1, we'll select our service in that region. For this demonstration, we can skip additional features like Cloud CDN or Cloud Armor. The default routing rules, which direct all traffic to our backend, are sufficient for our needs. After the load balancer is provisioned, we need to configure our domain's DNS settings. If you're using Google Cloud's DNS service, you'll need to create an A record that points your domain to the load balancer's IP address. If you're using a different domain registrar or DNS system, the process is similar. You just need to ensure your domain points to the provided IP address. When we check the certificate section, we'll see our Google Cloud Managed certificate in a provisioning state. During this time, Google Cloud is working with the certificate authority to sign the certificate, which involves performing the HTTP ACME challenge on our service. This process typically takes a few minutes, and you'll need to periodically refresh the page to check the provisioning status. While waiting for the certificate to provision, we can examine how these resources would be defined in Terraform. The Terraform configuration mirrors what we've set up in the console. It includes our static global IP address for the front end, a Google Certificate Manager certificate integrated with our load balancing resources, and a health check. The certificate resource itself is defined by specifying our domain name and indicating that it's a managed certificate for use in Google Cloud. Once the certificate becomes active, we can test our service using our new domain. At this point, we'll have our service running on HTTPS with our new domain and certificate. While Terraform is an excellent way to manage these certificates, we have other options available, including API calls, the G-Cloud command line tool, or even Python scripts. To demonstrate the flexibility of Google's certificate management system, we can set up a secondary certificate. While we won't delve deeply into the code, it's worth noting that we can use the Python SDK for Google Cloud Compute Engine to create additional certificates. Although you could simply add another domain to your existing certificate, there may be scenarios where you want separate certificates. The Python SDK provides a quick and efficient way to accomplish this. Before running any Python scripts for certificate management, we need to ensure we have the Google Cloud Compute Library installed. After running our script, we can refresh the load balancer view to see our secondary certificate. Like the first certificate, this new one needs to be provisioned through the same process, pointing the domain to our load balancer's IP address and waiting for the certificate provisioning to complete. To monitor and manage all your Google managed certificates, you can use the Certificate Manager in the Cloud Console. Specifically, you'll want to navigate to the Classic Certificates section. Here you can view all your certificates, check their statuses, and see how they're being used in your cloud load balancers. If you'd like to support the channel, consider starting a free trial of our new design tool, which is linked in the description, and let us know what you think. We'll include all the code and diagram files in the description, and we'll keep an eye on the comment section for any questions. Thank you very much for watching to the end, and please enjoy responsibly.